Antioxidants. You know what they are. Nutrients like vitamin C or vitamin E that supposedly fight the free radicals that damage our bodies. For years, we were told that drinking extra orange juice or taking mega doses of vitamin C could stop a cold, or that taking vitamin E pills would protect our heart, brain and skin. You probably noticed that antioxidants are everywhere. They're not hard to miss. Not only are the supplement shelves at the health food and grocery stores teeming with antioxidants, they're in our food and our bottled water. They're featured in nearly every energy drink. Even soda beverages now boast of their antioxidant content. In fact, the journal Age reports that consumption of antioxidant products has increased from less than 1% of the population in the 1950s to about 45% today. And recently, the Global New Product Database recorded some 703 new foods and dietary supplements that refer to antioxidants, a 400% increase from 5 years earlier. In short, our culture is saturated with the notion that supplementing our diets with conventional antioxidants like vitamin C can somehow protect our health. But all this begs the question, can these antioxidant-containing foods and supplements that we regularly consume truly be beneficial for us? Can they really protect us from disease and improve our level of health? Perhaps a cautionary tale from ancient history can help provide an answer. In the 2nd century BC, Chinese Emperor Qin Shi Huang, who was also known as China's first emperor, was obsessed with finding an elixir of life that would help him achieve immortality. To this end, he continually had his court doctors and scientists investigate any potential source of such an elixir. He also sent out large groups of explorers in an effort to find a source of eternal life. Eventually, the emperor's inner circle of doctors began giving him pills that contained small amounts of mercury, which they believed would help extend his life. Ironically, Emperor Qin Shi Huang eventually died a premature death, with mercury poisoning being the cause. The account of Emperor Qin Shi Huang can apply to our situation today. It can certainly be said that most of us would love to have some sort of elixir of life, a pill, a drink or a food that could improve our health, enhance our looks, and extend our life. The proliferation of antioxidant products and the constant telling of the antioxidant story have only fueled that pursuit. We've been led to believe that antioxidant vitamins or foods enriched with conventional antioxidants can help fight free radicals and lower oxidative stress. Like Emperor Qin Shi Huang, however, is it possible that we have been misled? Could the truth be that these products we've been taking all these years in an effort to improve our health are actually causing more harm than good? Recent research demonstrates that certain antioxidants, such as vitamin C and vitamin E, not only offer no antioxidant protection, but can create negative and oxidizing effects in our bodies as well. What can be done to ensure we are providing our bodies with the necessary nutrients and supplements? Is there a solution that can help us effectively fight oxidative stress and supply our bodies with the types of antioxidants that can provide optimal health? On this CD, renowned scientist and 2-time Nobel Prize nominee, Dr. Joe McCord, discusses all of these topics and more. In the next few minutes, you'll learn all about the antioxidant myth, how it came to be, and why it may be a significant health concern for all of us. You'll also hear Dr. McCord discuss his breakthrough work in the field of free radical biology and how it has forever altered the way we look at free radicals and antioxidants today. More importantly, Dr. McCord will also share exciting information regarding a revolutionary product that you've likely never heard about, a product that has been clinically proven to slow cell aging and essentially eliminate the increase in oxidative stress that occurs as we age. So listen closely, and what you learn today may enhance your health forever.
Hello, everybody. This is Clint McKinley. I'm here today with Dr. Joe McCord for a conversation about Protandim, the science behind it, and in general, the science of antioxidants and free radicals. Thank you for joining me today, Dr. McCord.
My pleasure.
You know, when you review your background and your experience, the question comes to mind, have you always been interested in science, or when in your life did that interest get sparked?
I was always interested in what made things tick, how things worked. When I was 10 years old, I guess, or 12, I had a chemistry set for Christmas, and the rest is history. So I had a pretty strong conviction that I wanted to do something in the science arena, and originally planned to be a chemical engineer. And my junior year in college, I guess, I became interested in biochemistry. I had a professor who thought that was a good fit and directed me toward graduate school in biochemistry.
And you went to Duke, and take us on a journey from there through your postgraduate studies and your career.
I entered Duke University as a 21-year-old graduate student and was very fortunate to have a project that really took off after the first year. First year is always a year of frustration. After that, we stumbled into something that turned out to be very, very important, and has really directed the rest of my career right up to this point. My doctoral dissertation work was the discovery of superoxide dismutase, and I stuck with it. When it's time to do postdoctoral work, additional work, I thought this is too good to walk away from, so I stayed in the same laboratory for 2 more years and became a junior faculty member in the Department of Medicine at Duke. Then I went to the University of South Alabama for about 13 years, where I was chairman of the Department of Biochemistry, charged with teaching medical students what they know about biochemistry in their first year. In 1990, moved to Denver, where I still remain.
With the University of Colorado today.
Correct. Right.
Now take us back to that moment in the lab when you were working with your mentor, working on your higher education studies at this time, and you discovered something that is world-renowned now as superoxide dismutase.
Correct.
How did that happen?
Not the way most people would imagine. Science doesn't usually work from a scientist saying, I have this grandiose idea, and setting about to prove it. Rather, it's years of stumbling around, making observations, and recognizing what's real, what's reproducible, and trying to piece together facts. And I was very fortunate to have Erwin Friedovich as my mentor. And his philosophy was anything that is real and reproducible should be noted, should be shared with other scientists, because it's a fact. It's a building block in the edifice of knowledge we're trying to put together. And sooner or later, it will become significant. It will become meaningful. And so the discovery of SOD was pretty much that. He had studied an enzyme called xanthine oxidase for years. Turned out to be that's one of the primary enzymes that makes free radicals in your body, which nobody realized at that point. And so the discovery of that fact, that there's an enzyme in living cells that can make reactive free radicals, was really wrapped up with the discovery of superoxide dismutase at the same time, because SOD, superoxide dismutase, eliminates those free radicals. And it was kind of a coincident then discovery of a source of radicals and an enzyme that gets rid of them, none of which was appreciated widely by scientists at the time.
Looking back now, it's amazing to think you were in your 20s at the time, were you not?
I was.
In your 20s when this SOD discovery takes place. Amazing how that shaped the rest of your life.
Yeah, it is. I think youth is sometimes underestimated. I see kids now who are in their teens and understand computers frontwards and backwards, and we probably should develop our children at a faster pace than we do and get them right into the deep stuff, because that's really what happened to me. And the discovery of superoxide dismutase was asking questions that were just lying there kind of in plain view, but they took some work, and it took a really smart man in the form of my mentor to know that these things were potentially important, and they certainly turned out to be that.
So at the time then when you made this discovery, it wasn't so much an aha moment. Did you appreciate then when it would become globally?
Not at all. There was an aha moment, but it's not what people would imagine. I mean, for me, I remember distinctly on the date. It was April 3rd, 1968. I remember going home after performing an experiment that was kind of puzzling. And I went home, sat down, and just started thinking about it. And I suddenly realized that there was the basis there for how superoxide dismutase could be working, something that, in other words, observations we had made for 10 years suddenly could fit into a logical, rational framework. That was the aha moment. And so the next day I designed an experiment to test it. That's what scientists do. They have a hypothesis and they test it. And actually, you try to disprove it, because supporting it often doesn't get you very far. If you work to support your hypothesis, you're never going to be a good scientist. So you should give it your best shot and then work to disprove that. And if you can't disprove it, then it's a pretty strong hypothesis. And that's what happened with SOD.
So from that date, 1968 to now, much has been learned. You've been at the forefront of this research ever since, over the last 41 years. Much has been learned about antioxidants, and more recently, the difference between direct antioxidants that we take in the body and more indirect or enzyme-related activity to fight free radicals. Right. Can you walk us through the evolution of that science and how we got to where we are today?
I can. The first question when we recognize that there's an enzyme that gets rid of free radicals is, what free radicals? Where are they coming from in the body? And is this a very localized phenomenon, or is it pervasive among all organisms that live on this planet? And very quickly we were able to establish it was pervasive. In fact, every organism that utilizes oxygen, which is almost every organism, had this enzyme activity. And that makes a very strong statement. It implied that it's there for a reason, and that organisms, if they all have it, you even suspect they might not be able to survive without it. And we set about to prove that and to test that hypothesis. And in fact created an organism from E. coli, which is a common bacterium that lives in the gut. And E. coli is peculiar in that it can live with oxygen and use oxygen. It can also live in the absence of oxygen. And what we did was we eliminated its SOD activity, and we're proposing that that would render it incapable of living in oxygen. And that's exactly what we saw. This organism could no longer live in oxygen, but if we took the oxygen away, it was perfectly normal. So its anaerobic life was unaffected in the absence of oxygen, but its life in oxygen was dramatically changed. And that was probably the experiment that convinced us this is not an artifact, it's not an accident. This is an enzyme that is playing a key role in the survival of all of us that breathe oxygen.
So from this time of learning about free radicals to now, there's been a movement in science promoting antioxidants.
Yes.
And many of these antioxidants that we hear about that are promoted popularly are direct antioxidants from food sources, or the antioxidant vitamins C and E primarily, and beta-carotene, carotenoids and so forth. What do we know now about the role of those type of antioxidants in fighting free radicals?
Well, when the problem was recognized that we make oxidants and we need protection, it was a short step to the concept that in some conditions we may make too many radicals and overwhelm our ability to scavenge them, creating a condition that we now describe as oxidative stress. That's when this thing gets out of balance and you make too many radicals. So scientists began to say, how can we correct that? And it turned out that oxidative stress was fairly rampant. So if you looked at various disease states, many diseases have now been realized to involve a shift in oxidative balance, a shift toward the oxidative side. They are diseases characterized by oxidative stress. And the question was, how can that balance be restored? And direct antioxidants was the first obvious approach. Molecules such as vitamin C, which happens to be a vitamin, but it's also a pretty good antioxidant, meaning it reacts well with free radicals and with oxidants. And so vitamin C was attempted to be used as a way of correcting oxidative stress. And for years and years, laboratory experiments were done because it's a natural product. It was marketed as an antioxidant. Clinical trials were done in various diseases. And it's only fairly recently we've realized the limitations of that approach. And in fact, that approach doesn't work very well and sometimes doesn't work at all. And sometimes it even makes matters worse because direct antioxidants can become pro-oxidants. They can actually create a bigger problem than the one you were originally trying to solve.
So what you're saying is just by taking vitamins, supplementing, say, vitamin C in your example, we may be doing more harm than good.
We may be. And an important part of why that is the case is that's not the way our body deals with that problem of oxidant production. We don't rely on direct antioxidants like vitamin C to get rid of the oxidants we produce. We rely on enzymes. Every reaction in our body is essentially catalyzed by an enzyme. And the definition of a catalyst is it promotes a specific reaction but is not consumed by the reaction. It enters, does its business, and exits, and it's unchanged, so it can do it again and again. And our body has a network of antioxidant enzymes, perhaps at least 20 or 30, maybe more, that work on various parts of this problem. Some of them repair the damage done by oxidants. Some of them scavenge and prevent the production of oxidants. And together, they provide a real defensive network against the damage done by oxidative stress. What became obvious is that direct antioxidants, things like vitamin C, weren't a good solution. And by this time, things had progressed to the point where we understood more about how genes are regulated, and we can go in and actually cause our DNA to express more or less of certain gene products. And that's where Protandim entered the picture. Protandim consists of 5 phytochemicals. They're naturally occurring products. And for reasons we probably don't understand, these products send messages to human or mammalian cells. And the message they send is directly to the DNA, and it says, make more of this gene or that gene. And the 5 phytochemicals in Protandim are all focused at sending a message to the genes controlling the antioxidant enzymes. The message is, make more.
So for the layperson who may be listening, can you give us an analogy of how a direct antioxidant works against free radicals and oxidative stress versus these antioxidant enzymes such as catalase and SOD?
Right. The main difference is that direct antioxidants react one molecule of antioxidant with one molecule of oxidant. So it's a chemical reaction. They're both destroyed, and the products are excreted from the body. So it's used up. It's a tiny package that is used up in the process. One-time use, and it's done. The difference between that mechanism and how antioxidant enzymes work is that the enzymes are catalysts. They very efficiently, very effectively promote the reaction of getting rid of free radicals, for example. And SOD does it by reacting the radical with itself, which is an interesting solution. So it's nice and tidy. There are no toxic byproducts. And the enzyme efficiency is just dramatic. One molecule of a direct antioxidant, as we said, can annihilate one free radical. One molecule of SOD, the enzyme, the catalyst, can react with up to 1 million free radicals every second after second. And that quickly becomes an enormous number compared to 1.
So 1 and done versus millions per second.
Yes. So that's why it's really apples and oranges in terms of mechanism of how these things solve the problem of oxidative stress. And yet the remarkable thing is they're trying to bring about the very same result. That is, they're trying to get rid of those free radicals. They're just doing it in different ways. One way of comparing direct antioxidants to indirect antioxidants is the analogy of a house that's on fire. If we imagine your body is the house and the fire is oxidative stress, you want to extinguish that fire. A direct antioxidant, such as a tiny dose of vitamin C, tiny meaning maybe a 1 gram capsule a day, would be equivalent to tossing a tumbler full of water on a house fire. It's a tiny increment, and the fire that happens to be hit by the water might be extinguished, but in the big picture, that's a trivial effect. Indirect antioxidants, on the other hand, might be analogous to a fireman arriving, hooking up a huge fire hose to a hydrant in front of the house, opening that hydrant. So now you have a continuous stream of antioxidant power, if you will, directed at this house. And to go back to the analogy of 1 versus a million per second, perhaps that fire hose could fill up 1,000 glasses every second, and it can do that second after second after second. So it's really pumping water. And that's kind of a dramatic illustration of the difference between this quantized, finite little bit of antioxidant delivery that's used up as opposed to a continuous, endless stream.
Well, a river certainly beats an eyedropper.
Exactly.
Listening to you say this, it's really a big paradigm shift and a sea change, really, in how we view antioxidants and how they really should be promoted for the betterment of health. Protandim taking this new approach. Can you talk to us a little bit about the science of Protandim? You mentioned the messenger going to the cell and talking to the DNA to produce this SOD or other antioxidant enzymes. From the time I swallow a Protandim tablet, walk me through some basic science as to what happens.
Let me give you yet another analogy, and I'll relate this to oxidative stress and the aging process. The process that goes on in the internal combustion engine of an automobile produces some of the same reactive byproducts, free radicals, that our cells produce, because the combustion process is pretty much the same chemistry. It goes slower in a cell than in your engine, but the products are not that different. When you buy a new car and drive it off the showroom floor, it's in pretty good balance, and it's like a young cell or a young human being. It has very little oxidative stress going on. As the car ages, the aging process means the combustion process is not so tightly controlled. The engine wears, the tolerances become greater, the fuel mixture and the oxygen mixture are not quite perfect, and you get a dirty burn, and a lot of pollutants, reactive, noxious things come out the exhaust pipe of that car. And cars, for the last few decades, have mandated by law a catalytic converter that cleans up that process catalytically. Very closely analogous to the way cells clean up the process when they burn their fuel. So on the car, it's part of the exhaust system, and it does a good job of completing the combustion process, cleaning it up. And so a new car has much cleaner exhaust if it has a catalytic converter. A cell is much better off with its antioxidant enzymes, which are its catalytic converter. If you look at the aging process and the fact that oxidative stress increases with aging, whether we're talking about cars or cells or human beings, you might say, wouldn't it be wonderful if we had a car that as it aged could grow its catalytic converter so it could take care of the increased amount of pollutants that are being produced by combustion? And you could put a new fresh catalytic converter or a bigger one on an old car and clean it up. And you might say, wouldn't it be wonderful if our cells could grow their catalytic converters? And in fact, that's exactly what Protandim does. Protandim increases the production of the cell's catalytic converters, the antioxidant enzymes, so that an old cell that's producing more of these byproducts because of age, wear, and tear can now clean up that excess free radical production, and that cell can restore its oxidative balance to the same level as a much younger cell. And in fact, in the clinical trial of Protandim, we saw this at the organismal level. In an adult human being, an 80-year-old, before taking Protandim, may have 2 or 3 times the oxidative stress level of a young 20-year-old, a healthy individual, both of them healthy, one of them older. After Protandim, that difference is completely eliminated. So let me state that very clearly. Protandim completely eliminated the age-dependent increase in markers of oxidative stress. So at the end of 30 days, you could draw blood from these two individuals, 180, 120, and you couldn't tell any difference, whereas before Protandim, there are about 3 times as many markers of oxidative stress in the older person than the younger.
So you're a couple years older than me, Dr. McCord. If we both spilled blood right now, would you be able to tell who is younger?
If you're taking Protandim, I couldn't tell. If you're not taking Protandim, yours would be higher than mine, in fact, because I am taking Protandim.
That's an incredible statement. So talk about the validation of that. What kind of verification or studies have been done to prove that? It sounds too good to be true. How have you proved it?
It does. And, aging is complex, and I don't want people to misunderstand what's meant by anti-aging properties. Chronological age obviously can't be changed. If you're 80 years old, you're still going to be 80 years old because that's measured in years. It's a chronological age. But biochemical age is something quite different. So we can measure biochemical indicators of aging, and the one we measured in our clinical trial is, the acronym is TBARS, and it's the most widely used single parameter for assessing aging or oxidative stress associated with aging. So more than 8,000 papers have been published using this marker as a marker for lipid peroxidation or aging. And it's quite dramatic and quite significant that Protandim is able to completely block this component, this facet of the aging process.
Dr. McCord, we hear a lot about glutathione being an important antioxidant. Is that true?
Definitely it's true. Glutathione is a metabolite produced by our body, so it's not like a vitamin. Vitamins, by definition, have to be taken in from another source. Our bodies can make glutathione. The enzymes that produce glutathione are, in fact, among these antioxidant enzymes, so they are controlled in the same way. And Protandim upregulates those enzymes that produce glutathione. So in a paper we published in early 2009, shows that cells, human cells, treated with Protandim produce about 3 times as much glutathione as without Protandim. And this is not by giving glutathione as a supplement or even giving precursors. It's simply by increasing the amounts of enzymes that our bodies normally have that make glutathione. The glutathione utilizing antioxidant enzymes are a subset of the total antioxidant enzymes, and very important. They carry a big part of the burden in protecting us from oxidants.
So how does glutathione work in conjunction or synergistically with the other enzymes such as SOD or catalase?
It's not involved directly with SOD or catalase. It's only involved with the enzymes that make glutathione, a family of enzymes called glutathione peroxidases. There are about 6 of those that use glutathione to help get rid of other oxidant products that are produced in the cell. And there's an important enzyme called glutathione reductase that recycles glutathione. So glutathione, with the help of these enzymes, actually is recyclable. It's a metabolite that helps a certain subset of oxidative enzyme, antioxidant enzymes, work efficiently. Glutathione is required up to a point. It can become rate limiting, but in most cases, it is not rate limiting. So if you add excess glutathione when you don't really need it, you're not going to get a change in the outcome. However, the enzymes that utilize glutathione will have an effect. So it's a rather complicated biochemical system, but it's fully understood by scientists. And by far, I think the best approach is to increase the enzymes that not only make glutathione, but the enzymes that utilize glutathione and recycle it. And Protandim can do all of that. And as I said, it's been demonstrated that Protandim can increase the steady-state glutathione concentration by 3-fold in cultured human cells.
Protandim has 2 patents, as we understand, and 1 that's pending. Can you walk us through what the patents are?
Patenting natural products is not always a simple process because you didn't invent that compound. A plant has been producing it for eons. But what is unique about Protandim is the composition. So it is 5 natural products that have been used in traditional medicine for many years, many hundreds of years. And what we found that resulted in the patents is that there is synergy among these 5 compounds. And that was a real discovery that was not evident prior to the laboratory work that led to that realization. Synergy means that the effect of a group of things working together, and those things could be human beings in an office situation, they could be chemical compounds all doing something similar. Synergy is when the net result of the 5 compounds working together exceeds the sum of their individual contributions. So if you add up what A, B, C, D, and E do, in the case of Protandim, the 5 working together have an effect 18 times greater than the sum of their parts. And that is a remarkable aspect to Protandim of how it works, and was largely responsible for the issuance of those patents. That's what makes the Protandim formula unique and, in fact, patentable. And it means that you can't get the effect of Protandim from one or another of those compounds. The synergy is what allows it to work effectively.
So what do the patents say, in essence?
The patents protect the composition. So it is a composition patent in both cases that are issued. And they say that Protandim works, this is its composition, and no one can copy this.
So it's safe. In other words, we can't have any copycat imitators of Protandim using the same preparation.
Correct.
Dr. McCord, I imagine back in 1968 when you made this discovery of superoxide dismutase, you probably didn't know then that some 40 years hence there'd be 20 some odd respected universities all studying on their own expense a preparation that you'd come up with for something such as Protandim. It must be an incredible thing to look back on. Give us a sense of what's being studied by what universities and what we're learning from those studies.
When this story finally became a story, that it was put together and we saw how Protandim worked and what it did, I began presenting it to groups of colleagues. That's the way academic science functions. And it was remarkable to me how readily accepted the concept was. I could present this to an audience, and the first time I did it, I was expecting all kinds of critics. And to my surprise, they got it. They got it instantly. They saw the ramifications. They saw that this was a long-awaited tool that would now allow them to answer questions that they may have been studying in their own laboratories for years. And so almost every time I presented it, there would be 2 or 3 or more colleagues approaching me afterwards saying, you know, I have a system in my lab where I think this could help me answer the question. So let's collaborate. Let's do an experiment to see what Protandim does in my system. And that has happened more than 20 times, probably 30 or 40 times. Some of those have progressed now to the stage of human clinical trials.
Well, it makes sense when you consider that oxidative stress creates the foothold for all of these difficult diseases to take root.
Right.
And when we recognize that, we look for ways to reduce oxidative stress. And since Protandim has come on the scene, you've personally received so much interest from all these academic institutions. Very exciting to continue to follow the progress of these studies. So, Dr. McCord, what exactly is the antioxidant myth?
The antioxidant myth is a realization by scientists. I don't know if it's attributable to any one scientist, but has become discussed in the last few years, and it centers on the recognition that taking direct antioxidants has not provided the solution that we all hoped it would for oxidative stress. And I think the myth, the choice of word there, is that, in fact, direct antioxidants, conventional direct antioxidants, can, under some circumstances, even make the problem worse rather than helping to fix the problem. And so there's a paradox. The use of direct antioxidants is what some scientists would call a double-edged sword. There are benefits in one direction and maybe problems in another direction. They're offsetting, and sometimes you come out on the losing end of that. Indirect antioxidants, on the other hand, which is how the ingredients of Protandim are described, don't have the downside. They cannot become pro-oxidants. So they provide the benefits. They provide them in exactly the way your cells would normally provide those benefits, using the very same enzymes, the very same tools to the cells, but without the possibility of inadvertent toxic side effects.
In the scientific lexicon, we hear the term McCord units when measuring superoxide dismutase. And of course, you have to come up with a way of measuring something once you find it. So if you measure something in McCord units, what exactly are you measuring?
When SOD was discovered, it stands apart from most run-of-the-mill enzymes because its substrate is a free radical that has very low stability. You can't just make up a test tube full of superoxide and have it stable. It would dissipate very quickly. And so a special assay procedure had to be devised for this enzyme kind of uniquely. And in the paper where we discovered the enzyme, described what it is, what it does, what it looks like, how it works, we also described the way to assay it so people in other labs could then confirm what we had said and use that tool to measure the enzyme. So that peculiar assay, which is uniquely designed for this enzyme, is called the McCord-Friedrich assay because we described it, published it.
And tell us, for the layman, the definition of the word assay.
Assay is simply to measure the amount of an enzyme activity that you have. Enzymes promote reactions, and an assay is a way of just measuring how much of it there is.
So for the people listening out there, Dr. McCord, why should everybody be taking Protandim?
I think the best answer to that is that everyone is aging at the very least. Some of us have other problems in addition to aging. So regardless of who we are, regardless of what age we are, our oxidative stress is relentlessly increasing year by year. There may be some lifestyle changes we could do to make little changes there, but it's really out of our hands unless we induce the production of more antioxidant enzymes. And that's the only way I've seen in the biomedical literature of putting a halt to that relentless increase in oxidative stress. And, it may be years, it may be decades before we fully understand the results of halting that relentless progression.
So if somebody takes Protandim who's over the age of 20, can you confirm that they can have the oxidative stress of a 20-year-old?
They already do have the oxidative stress if they're 20. If they're over 20, it will decrease. It decreases in virtually every individual we've examined. And what remains to be seen is the extent of the benefits of that reduction. And scientists are very excited. My colleagues are convinced that there will be benefits. And I think lay people maybe are more skeptical. They'll wait and see the solution, the results of those studies. But, we will know. And we have the option right now to intervene, to slow that progression. Some will do it now, some will choose to wait. But I think everyone stands to benefit, at least potentially.
Our guest today has been Dr. McCord, who has been at the forefront of antioxidant and free radical science for many years. It started as a child for Christmas when he received his first chemistry set, blossomed at Duke University, where as a postgraduate student he discovered superoxide dismutase, continued over the years in academic circles, and is now culminating with the creation and science behind Protandim. I'm Clint McKinley. Thanks for listening.
We would like to remind those listening that Protandim is a dietary supplement, not a drug. In the United States, a dietary supplement cannot legally be sold to prevent, treat, mitigate, or cure a disease or diseases, such as those which have just been discussed. Nonetheless, much scientific research is conducted in labs, or on persons who have diseases, or on signs or symptoms of diseases which involve the use of substances that are food in nature. We can learn a lot from those studies that can result in better food or food supplements, or in newly discovered benefits from the consumption of a product such as Protandim.